Hello, my name is Fernanda Sobral, and today I'm going to solve quizzes number 2 and 3 from week 7. So we're going to start with quiz number 3. So the sentence says, the wave function for a wave on a taut string is y equals, y in terms of x and t equals 0.35 meters times the sine of 10 pi t minus 3 pi x plus b fourths, where x is in meters and t is in seconds. And letter A asks what is the average rate at which energy is transmitted along the string if the linear mass density is 75. So here we have the information we're given. So the average rate at which power travels is also known as power. So P, in this case, equals mu times omega times the amplitude squared times B divided by 2. So we have mu, we have mu as it is the density, the linear mass density, and it is given in grams per meter. So we're going to turn it into kilograms per meter. So it's this. We also have omega, which, as we know, is the number that goes with the time in this equation. We have the amplitude, which equals this. It's always the number that multiplies the sinusoidal function. And the velocity can be calculated as omega divided by k, which we both have here. So it's 10 pi divided by 3 pi, which is 10/3. And in this case, it will be negative, but we're going to take the absolute value. So we cannot substitute all of this in here. And once we make the calculations, we have that the power equals 15.11 watts, which is almost equal to 15 watts. Okay? So that's it for number A. Letter A, sorry. And letter B asks us energy contained in each cycle of the wave. So first, we need to find the frequency, and the frequency would be equal to omega divided by 2 pi, which equals 5. So this means 5 minutes. That the frequency means that it makes 5 turns per second. So we can also see it as 1/5, which would mean it takes 0.2 seconds for each cycle to happen. So energy in one cycle should be equal to the power, which is the energy, we can say the average rate at which the energy travels, times this period, which is the time it takes for it to take one turn. So we can eliminate the seconds here, and we end up with 3 joules per second. So that is the energy in each cycle. Okay, so now we're going to solve quiz 2. So this quiz says, transfer pulses travel with a speed of 200 meters per second along a taut copper wire whose diameter is 1.5 millimeters. What is the tension in the wire? And the density of copper equals 8.92 grams per cubic centimeter. So we have this equation here, which we know relates density, linear mass density, velocity, and the force. So from here, we can know that the force should be equal to the velocity squared times mu. So we can calculate mu as the density times the area, as we're giving the density for this value. So at the end, the force would end up being the velocity squared times the density times the area. So the density in kilograms per cubic meter, which are the units we're using here for force, is 8,920. So we're going to multiply this times the area, which is pi times the radius squared. So it's pi times, we're given here the diameter, so it's 1. Well, it's not 1.50 because we need it in meters, so it's meters, decimeter, centimeter, millimeter. 15 divided by 2, the diameter. So it's pi times the radius squared. Times 200 squared, which is the velocity. So this should be equal to the force, and at the end we obtain a value for the force that is equal to 630.5 newtons. So this is the tension in the copper wire. And the second one says transverse waves travel with a speed of 20 meters per second in a string under a tension of 60 newtons. What tension is required for a wave speed of 30 meters per second in the same string? So we're giving some information that when the velocity is 20, the force equals 6 newtons. Well, here it's 20 meters per second. And we know that for the copper wire it will have the same, well, it's not a copper wire in this case, it's just a string. So it will have the same value of mu, which we know is equal to F divided by the velocity squared. So therefore mu should be equal to 6 divided by 20 squared. So from this we can calculate the force with the formula we obtained before, which is velocity squared times mu. If we want a velocity of 30 times 6 divided by 20 squared, we'd get a force of 30.5 newtons, which is what is needed for it to travel at this velocity. And that's all. Thank you.